Okay, today what we want to talk about are monomials and then products of monomials as well. So first thing we want to talk about is what is a monomial. It's a number, a variable, or a product of number and one or more variables. So under here, what we want to do is we want to decide whether or not 1, 2, 3, 4, 5 are actually monomials, okay? And then we're going to go ahead and give the reason why. Okay, so for 1, we would say yes, this is a monomial. The reason why it's a monomial is because it's a constant, okay? It's a monomial is a number, okay? So that would be our reason why, okay? For number 2, no, because it says it can be a product of a number and one or more variables, but certainly not a sum, okay? Number 3, yes. That is a monomial because a monomial is a variable as well. Okay, so we have that. For number 4, we're going to say no. Okay, because when we have a denominator as a variable, that means that it cannot be a monomial. Okay, so no denominator of a variable. Okay. But for 5, we're going to say yes, because it has a constant as the denominator. In that case, it can work. Okay? So go ahead and, if you need to pause, fill out those reasons, and we're going to go ahead and continue on. All right, so now we're going to talk about the product of powers property. Okay, there's going to be 3 different properties we're going to be talking about in these notes. And really what's going to happen is I'm going to do the problems on the left side, and what you'll end up doing is you'll be doing the ones on the right side on your own. And we'll go over those in class. So if I have b to the 3rd, and that should be times, that should be a multiplication symbol there. Oh, here we go. If I have b to the 3rd times b to the 5th, it's going to be b to the 8th, okay? The reason why is we're not, again, this is a multiplication property. We're multiplying these two. You're going to add the exponents. That's basically what the product of powers property is. So if I have 5 to the 3rd times 5 to the 6th, I'm going to just add 3 and 6 together, and I'll get 5 to the 9th. X to the 2nd times x to the 3rd times x to the 4th. Again, we're just going to put x down, add 2 and 3 and 4, and we'll put another 9. 3 times 3 to the 5th. This is where you might make a mistake, okay? But what we need to remember is that 3 has an understood exponent of 1. So 1 plus 5 is going to be 6, okay? Because 3 to the 1st power is just plain old 3. So we need to understand that if it's just a constant without an exponent, that its exponent is 1. For number 4, -2 times -2 to the 4th. Again, I need to understand that there's an exponent of 1 there beside -2. So it's going to be -2 to the 5th. Okay, so the next thing that we want to do is we want to go ahead and look at these a little bit that we have. And what I'm going to do with 9, 10, 11, and 12 is I need to break out my 2 and 8. So it's going to be 2 times 8 times x to the 4th times x squared, okay? So that's how we're going to work that. So it'd be x to the 4 plus 2. 2 times 8 is 16 times x to the 6th. And that's all we're going to do. Okay, so I multiplied the 2 and the 8, okay, and then I just used my property that we talked about, because really all I'm doing is I'm I'm combining these two exponents. All right, next. I have 5, and then I have x to the 7th and x to the 6th, so it's going to be x to the 13th. All right, so let's take a look here. So I have 4 times negative 7, so I'll have negative 28, and x to the 1st, x to the 2nd, so it's x to the 3rd, y to the 5th, y to the 3rd. 5 plus 3 is 8. All right, let's get into it for this number 12. Here comes some fun, right? So I have, let's do our numbers first. 2 times 2 times negative 3. So I'll have negative 12. All right. So I'm going to go on to my a to the 4th, 3rd, and 1st. So 4 plus 3 plus 1. So I'll get a to the 8th. And there's no b in this first one. That's okay. B to the 2nd. So I have b. 2 plus 3 is 5. Okay, and there we go. That's it. Go ahead and try these problems on the right, in the right column on your own. Okay, next we have power of a property, or I'm sorry, power of a power property. So what we're looking at here, previously what we did is we were multiplying different terms or multiplying different monomials. Okay, we were multiplying those monomials or those terms together, and then because they were like terms, we were just adding the monomials up. Here what we're doing is we're taking that monomial, b to the 3rd, and we're raising it to the power of 5. When we're doing a power of a power, that's when we're going to multiply our exponents. Okay, so let's go ahead and take a look at our examples that we have here. Again, all we're doing is we're multiplying the exponents. So if I have 3 to the 5th to the 2nd, it's just going to be 3 to the 10th. That's it. Y squared to the 4th, so we'd have y to the 8th. Negative 3 to the 3rd squared, so that would be 3 times 2, negative 3 to the 6th. And a plus 1 squared to the 5th power. All right. Now, pay attention to this. You'll see something like this later on. This is all we're doing at this time. We're going to leave it as a plus 1 in parentheses, and then multiply the 2 times 5, you get 10. That's it with this. Okay, we're not doing anything else with it right now. All right, finally, power of a product property. Okay, so what that means is that we're going to take the power of a monomial, and we're probably going to have to do some multiplication as well. So if I have 5x squared, okay, so that means I'm going to square my 5 and get 25, and then write x squared. All right, because x would be to the power of 1, right? So x squared would be 1 times 2, which is 2. So then I have 4yz to the 3rd power. 4yz to the 3rd power. So I have 4 to the 3rd power, which is going to be 64. 4 times 4 times 4. And then I have y to the 3rd, z to the 3rd. Negative 2w all squared. So I would have negative 2 squared times w squared, which in turn is going to be 4w squared. Okay, and now finally I have the negative with the 2w squared, so that's going to be a little bit different. I'm going to square my 2, which I have 4w squared, but it all is surrounded by a negative sign. So that entire value is going to be negative. Next, now we're going to go ahead and kick it up a notch, all right? And we have 3x to the fourth all cubed. So 3 times 3 times 3, we have 27. X to the 4 times 3, 12, all right? And here, 6 to the third would be 216. A, remember we're multiplying here. A to the third, B to the sixth. All right, we're not adding these, we're multiplying them. Negative 7, x squared, y to the third, all that entire quantity squared. So negative 7 squared would be 49. Okay, x squared to the second power would be x to the fourth. Y to the third to the second power would be y to the sixth. And finally, we have negative 3ab to the third. So negative 3 to the third would give us a negative 27. A to the third, and multiply 3 times 3 for the b to the ninth. Okay, so if you paused and kept going, what I'd like you to do at this time is to go ahead and answer these problems in the right-hand column on your own, and we'll talk about them in class tomorrow. Thank you.